Hello everyone. So now in today's session we'll see introduction to data analysis and data types. So once after understanding the importance of analytics across business domains, let's see what is data analysis and how this is different than data analytics. So this data analysis and data analytics terminology sounds similar, but there is a thin difference between data analysis and data analytics that we are going to highlight in this session. So in this session we'll gain answers to what is data analysis, we'll see its definition, process, difference between data analysis and data analytics, and then we'll see different types of data. So first we'll understand what is data, what is the basis of categorization for data, and what are the different data types. So this is data analysis introduction. So when I say analysis, this is nothing but referring to breaking a whole into its separate components for individual examination. So data analysis is a process for obtaining raw data and converting it into information useful for decision making by users. So data is collected and analyzed to answer questions, test hypotheses, or disprove theories. So when I say data analysis, it's basically the data that you have stored in your data warehouses or data marts, which are the historical repositories of the data, understanding the pattern of the data. You can use the data to plot some trend analysis, identify the behavior from that particular data, and then come with some conclusion that this is how my customer performance was, this is how my product performed in past, and you can definitely take that information as an input to improve or to enhance your business revenue or profit. So there are various statisticians and people who provide a definition for data analysis. So according to a statistician, John Tukey, who was born in 1915, who defined data analysis was something like this. So this is nothing but procedures for analyzing data, techniques for interpreting the results of such procedures, ways of planning the gathering of data to make its analysis easier, more precise or more accurate, and all the machinery and results of mathematical statistics which apply to analyzing data. So you'll find many definitions of data analysis. This was one given by this statistician. So there are various components of data analysis. So we have something called as process. So there are several processes that can be distinguished, and these phases are iterative. In the feedback from later phases may result in additional work in the earlier phases. So this is a cyclic process which starts with some particular process and ends with some particular process, and if the prior processes are not up to the mark, then you need to go back and perform those cleansing, and you need to correct those steps and get the data at the desired level before you continue with the further processes. So there are various steps involved in this. So step 1 is define your questions, and then step 2 is set clear measurement priorities, and then you have this collecting data, and then you have this interpreting results, and then we have this analyzing data, and then comes the data cleaning. So we'll see how these steps are performed one after the other, and how we arrive at some clean data that is used in your analysis or the analytics that you're performing in this data scientist domain. So when I say data analysis looks backwards over time, providing marketers with a historical view of what has happened. So as I told you before, this helps you understanding your past business data, your product data, or your customer data, and then you can draw some conclusion from that past information, that historical information, when you predict something for future. Whereas when I say data analytics, this analytics looks forward to model the future or predict a result. For example, we can take the same shopping mall example, where if a customer visits repeatedly, and every time if he buy a item of a particular type, and if his information is stored in that shopping mall's OLTP systems, that shopping mall can analyze that particular customer's data and can come up with some promotional schemes or offers, some lucrative offers which they can give to that particular customer to push him for some items that he hasn't bought yet, that he never bought in past, and they can enhance their revenue or profit. So when you understand the customer behavior pattern, and with that when you start predicting for future, that is called as data analytics. So both analysis and analytics provide the insight marketers use to value customers accurately. So these are some similarities between data analysis and data analytics. So they help you value customers accurately, target the right audience. So you can, in case if you have lots of data stored, you can actually figure it out, who all are the customers whom you can target, and who all are the customers who were like one-time buyers, and they'll not come or visit your outlet again, and you can discard their data and focus mostly on the ones who can be your potential buyer again. This helps you improve the effectiveness of their marketing budget. So both help marketers transform customer data by exploring and analyzing that data to help uncover unknown patterns, opportunities, insights that can drive proactive and evidence-based decision making. So these are some similarities between data analysis and data analytics. Again, there are various ways we can define data. So when you define data, this data is nothing but set of values of qualitative or quantitative type. So data is set of values of qualitative or quantitative variables. So these are the broad categories of data. So the data which is in textual format, which is in descriptive format, is mostly your qualitative data, and the data that you can measure in terms of numbers is your quantitative data. So the qualitative data is descriptive in nature. It describes an attribute that can be observed but not measured. For example, the flavors of ice cream, which can be vanilla or butterscotch or chocolate, or the hair color, which can be blonde or brunette or black, or the profession type, that can be engineer or tailor or consultant. Okay, these things can only be observed, these things can only be felt, this cannot be measured. Such data is called as qualitative data. But in some other cases, you have some data that can be measured in terms of numbers, that is called as your quantitative data. So this data is numeric in measure. It captures the measure of an attribute, for example height of students, which can be approximately say 5 feet 6 inches, or 5 feet 9 inches, or 5 feet 3 inches, or 5 feet 5 inches. Okay, so all these numbers can be measured. Or the cost of a particular item, which can be 120.5 or 130.2 or 111.6 or 90.8, or age of a person, which can be 34 or 26 or 67 or 53. So as you see, all these data can be measured, but in case of qualitative, that this data can only be observed, or it can be only experienced, it cannot be measured. This is how we segregate, we classify data in qualitative and the quantitative type, which are the two broad categories of data. So there are some factors on the basis of which we do data categorization. So it's the type of the data, the processing of the data, the form of the data, the source of data generation, size. So there are various factors which help you in data categorization. For example, when I say types of data, again as we discussed in previous slide, we can categorize the data as the qualitative or quantitative. This qualitative data at times is also called as categorical data. So we have different types of variables in this categorical category. For example, this binary and nominal and ordinal and ratio and interval. All these are different types of variables that comes under this categorical category. You are going to learn more about these variables in your data science module. Then we have this quantitative random variables, which can be classified as discrete or continuous. Okay, so we have discrete numbers and we have continuous numbers, okay, which defines your qualitative random variable data. So when I say discrete data, this is some numerical data which has finite number of possible values. Examples: number of people in a room, number of items in a basket, number of hours in a day. Okay, all this data represent some numerical data which is discrete in nature. Then we have this continuous data, which is again numerical data, and this will have infinite number of possible values. For example, height of people, weight of people, or cells made in an organization, or the account balance that you have. All this data is again numerical, but this data is continuous in nature. So continuous data is usually in decimals. Now there are various data types in quantitative category. So these are few examples of quantitative data types, and we have classified them in terms of the measuring unit and the attribute, whether they are discrete or continuous. So for example, you have this fuel in car, which can be empty or full. So this can be categorized as the discrete data. If you want its equivalent continuous form, this can be like fuel volumes in liters or gallons. But when you describe it only as empty or full, this we call as discrete. But when you start defining in terms of the liters and the gallons, then this is called as continuous. Then we have this height of trees in a forest, which could be tall or medium or short. But when you start measuring it in terms of meters or centimeters, then you call this as continuous data. But when you describe only as tall or medium or short, we call this as discrete data. Or it can be the performance of a tailor in a garment factory, which could be poor or average or good. This is the discrete category of the data. When you want its equivalent continuous category, this could be the pieces stretched or the number of hours worked in the factory. Or it could be, the next example could be home deliveries of pizzas. So in case if you want to describe in the form of discrete data, this could be the number of late deliveries or number of deliveries which were on time. In terms of continuous, this could be the time per delivery. In terms of student performance, the various grades that are allocated or that are assigned to students describe the discrete nature of the data, and the percentage marks scored by the students is nothing but the continuous data. So here we had few examples explaining us the difference between the discrete and the continuous form of the data. Then we classify data based on the kind of processing which is required on the data. Most of the time your transactional systems capture your data in raw format, and this data has to be converted into a structured format so that the data can be easily analyzed, or the data can be used for any kind of analytics. So what it means is the data from the source input to the data processing process. Raw data may have errors, not validated. Okay, same data can be repeated several times. It can have some undefined format, or it can be dubious or requiring confirmation or citation on. So your raw data could be in any of these forms, which definitely needs cleansing, a good cleansing, and then only this data when used in analytics and generate some result, you will be able to draw some meaningful inferences from the result. For example, if the correct format is not specified in an application form, the date of birth data can take many forms, such as, it can be written as 31st January 1990 or 31st/01/1990 or 31st/190 or 31st Jan 90. This raw data needs to be processed to a common format for further use by systems or humans. There are some words, or some keywords that we refer by its many forms. For example, if you are referring to let's say a country USA, that can be referred as u.s.a or simply USA or u.s. or US. If you are not able to standardize this data, then these four occurrences of USA, u.s.a, USA, u.s. and US will be considered as four different countries. But that all these keywords are representing the same country. So you need some mean or way to cleanse the data and tell the end user that tell your application that all these occurrences of USA are representing the same country. So you have to have some mechanism to standardize these values and some mechanism to cleanse this data. Only then doing some analysis on this data will make sense. When you say processed data, when you define processed data, what it means, data after processing for issues in the raw data. This is some data which is ready for analysis. One can easily consume this data for any kind of analytics or model or algorithm that you want to run on. Processing includes scrubbing, cleansing, merging, formatting, transforming, and so on. All data processing steps documented. For example, when I say recoding, number of children filled in a survey form may be left blank by people who don't have children. This have to be coded as 0, which is a valid value for this variable. But if it is left blank, that may create some chaos or issues when you are using that information for some analysis. When you say deriving, this is end of day sale amount for a store, which can be calculated by summing up all the transactions in a day. Then we do the categorization based on data collection type. So data can be categorized categorized in different types. So you have this, there is something called as main types, and there are other types. So under this main types, we have this data, gathered or collected from census, or the data capturing systems, or the observational study, or the convenience sample, or the randomized trial, that you have. When I say other types, that includes the prediction study, the studies over time, the retrospective form of the data, the cross sectional and the longitudinal data. So we'll see the different data collection types and what it means. So the first type is the census data, which is the systematic collection of data about all members of population. Then we have this observational study. This is the collection of data to draw inference of outcome of a treatment on subjects. It is not in control of the investigator to assign the subjects either to the test or the control groups. Then we have this convenience sample, which is collection of data from a sample where the subjects are selected because of their convenient accessibility and proximity to the researcher. Then we have this randomized trial, which is collection of data to draw inference of outcome of a treatment on subjects. The investigator randomly allocates the subjects to either the test or the control group. We are going to see these topics more in detail when you will start actual predictive modeling. So you will be covering this under data science, and then you will see its practical implementation under the predictive modeling that you can do either in SAS or R or Python like tools. Then we have this predictive study data, which is where we have this training data and testing data. So training data is nothing but a set of data that is used for discovering potential relationships, and the testing data is a set of data that is used for assessing the strength and robustness of a predictive relationship. Then we have data which is collected by studies over time, which can be the cross-sectional or the longitudinal data. In cross-sectional, we have data collected by observing many subjects at the same time, snapshot view of the subjects, or cross-section of the population. Then we have this longitudinal data, which is data collected on repeated observation of the same set of variables over a period of time. Then we have this retrospective data, which is collection of data of events that have already occurred in past. Then after, we have this time series data, which is a sequence of data points measured typically at successive points in times spaced at uniform time intervals. For example, the data that you have collected every year or every quarter or at the end of every day. So you can decide that pattern of the data frequency, and you can classify that as time series data. So this is one dimensional data and has a natural temporal ordering. So there is some particular order which is followed, so it could be the day wise, or it could be the week wise, or the month wise, or the year wise. Whichever standard you have followed, data is measured, based on that standard. Then you have the spatial data, which is the data that have a spatial or geographical component, which means they have a location on Earth. So there is some location or some physical path of that particular data. Then we have this cross-section data, which refers to the data collected by observing many subjects, such as individuals, organizations, or countries or regions at the same time, and this we define as cross-section data. And this data is one-dimensional in nature. Then we have this panel data. So panel data contains observations of multiple phenomena obtained over multiple time periods for the same organizations or individuals. Then comes the forms of the data. So as we discussed at the beginning of the session, most of the time in your production environment, the data comes in different formats. The data can come in the structured form or the unstructured form or the semi-structured form. And before you start analyzing the data, you have to ensure that the data is properly cleansed, and then only it is used as input for the analysis. So here we'll describe different forms of the data. The first is the structured data. This is some data that can be organized in well-defined structures. Structures include arrays or vectors or tables or other data repository formats. There exists some relationships between the different entities that you have in the structured data. So relationships in data defined within the structure. For example, we can consider the student data given here as the structured data where we have variables like ID, and then we have the first name, and we have last name, and then we have date of joining and batch number and course name and address 1, address 2, and the city, as the variable names. So as you see, you have some column header, some variable name which is describing the structure, and then you have some data maintained under it. In terms of structured data, the data that we maintain, that we store in almost all RDBMSs, the relational database management systems, that data we call as structured data. So the data that you have stored in the Oracle database, or the MySQL database, or the MS SQL database, or the Sybase database is considered as a structured data, because that data has a well defined format, and the data is stored or maintained under that particular format. When I say semi-structured data does not conform to a formal defined structure, but entities belongs to classes with attributes. Data cannot be processed as efficiently as the structured data. For example, the data that you have captured or that you have stored in the HTML or the XML format, where every information is stored in the form of tags, is considered as a semi-structured data. So this is not something that is absolutely in a very unknown format. Here the format of the data is known, the flow of the data is known, but again this data cannot be considered as good as the structured data, the data that you have stored in the tabular format or in various RDBMSs. Then we have this unstructured category of data, which is some raw data that you have captured through the web applications, or that you have captured through the handheld devices which are configured across organizations, or the data that you have captured from the social media sites that you have. It could be your WhatsApp data, Twitter data, the Facebook data, okay, the data which has no particular format. So this data cannot be considered as semi-structured or structured. This data comes under the category of unstructured. So in this case, the data is organized in an arbitrary manner with no predefined structure. The types of content includes the free text, documents, images and videos. Example, the resume document of a student with free text and images, or the data that you have captured or that you have gathered from the social media sites, or various applications, mobile apps or the web apps that you have. This data comes under unstructured category, and this data has to be converted into a structured format before you start analyzing this data in a meaningful manner. Then we have something called as batch data and the real-time data. This is something which is related to two processes that we perform most of the time in production environment, called as real-time processing and batch processing. So there are some processes which, when occur, they need to be immediately updated in your database or in your data repository systems. For example, when a particular customer withdraws money from ATM, this transaction needs to be immediately recorded in the bank's database, and the balance of that particular customer needs to reduce accordingly. If this transaction is delayed for a while, then that customer may withdraw the money several times because his balance has not reduced. So this transaction has to be reflected in the bank's database immediately. The balance should go down, and then accordingly the further transaction should be allowed or they should not be allowed. But there are certain transactions, there are some processes that we can delay and we can perform in batch. For example, when it comes to sending monthly statements to customers for their transactions that they perform throughout the month, this activity can be performed only once in a month, maybe at the end of the month or at the beginning of the month. Okay, this need not be performed every day. The customer need not be sent a statement every day for their transactions. Okay, this could be done once in a month, or some frequency which has been decided by the financial institution. In unstructured and structured data category, we mostly perform two types of processing, and accordingly we categorize the data as the batch data and the real-time data. So basically, whenever you perform any kind of processing in your business environment, it's classified as real-time processing and the batch processing. So when I say real-time processing, it's basically some processing that needs to be immediately recorded in your data capturing systems. Only then the data integrity is maintained. But batch processing is something which can be delayed, and it is performed at some specific interval. For example, when a customer withdraws money from ATM, this particular processing or transaction needs to be immediately recorded in the bank's database, and accordingly the balance amount of the customer must reduce. If it is not immediately captured and reflected in the database, then that balance will show, as the previous balance, and the customer, may withdraw that money, several times. So this transaction needs to be reflected immediately in the database. But when it comes to sending monthly statements, to customers in a bank, okay, they need not go for, they need not make this as their daily activity. Whereas what they can do, they can send this statements, once in a month, maybe at the end of the month or at the beginning of the month. So this particular activity can be pushed or can be performed in bulk or in batch size, at some particular specific interval. But this is not possible when you perform some real-time transaction, like withdrawing money from ATM, or when a customer changes the address from one location to the other. Okay, this needs to be immediately reflected in the bank's database. So when I say batch data, this is some data collected in a batch mode at periodic intervals. So there is a delay in the availability of data as a certain periodicity is maintained for its collection. Whereas in real-time data is collected in real time. The data is delivered as it gets generated. There is no delay in timeliness of data provided. In case if there is a delay, this will impact the accuracy of the data or the transactions, and because of which the data integrity will go down. So that's the difference between batch data and the real-time data, okay, based on the two types of processing that we perform in the production environment: batch processing and real-time processing. Thank you very much.